What a cool project, first of all, and it's solving a real need. That's what I love about it. You're solving a real world problem, right? It's the first project that we talked about first is cool, but that stuff exists. This doesn't exist, so you can make some real impact and really help people. So that is very impressive. Hello and welcome to the PyBites podcast, where we talk about Python, career, and mindset. We're your hosts. I'm Julian Sequeira.
And I am Bob Beldebos. If you're looking to improve your Python, your career, and learn the mindset for success, this is the podcast for you. Let's get started.
Hey everyone, welcome back to the PyBites podcast. I am Julian. I am here with a very special guest. I know I say this every time we have a guest, but this time I mean it. Sorry, everyone else. I'm here with Victoria Kolmac. Victoria, welcome to the podcast.
Thank you. Thank you, Julian. I'm good. I'm glad to be here. Very excited.
And I believe this is your first podcast.
It is. I'm a little nervous, but you know what? We'll go with the flow, see what happens. Very keen to be here in the presence of a great podcast leader in the field. Wherever he is. I'm not sure if he's
All right. Yeah. No, thank you. I'm stoked to have you here. This is a very everyone listening and watching, this is a very special podcast to me, this episode, because Victoria is actually my cousin. Technically, she's my second cousin, but my cousin nonetheless. And one of the reasons I wanted to have her on here, aside from the fact that she's just awesome and extremely intelligent, way more intelligent than me, but it's because she uses Python. So we were actually at her birthday party last weekend, and we got into a great conversation about how she's using Python at university and beyond, and all the different things she's doing with it. And I said, you have to come on the podcast. So here we are, following through on that. But I don't want to steal your thunder, Victoria. Do you want to do a quick introduction for everyone who doesn't know you, and just tell us about yourself before we jump in?
Yes. Yeah. Thank you. So, so as Julian mentioned, I am first and foremost his cousin. But so a bit about me. I'm a university student currently. I do biomedical engineering and computer science. I study at University of Sydney. My passion really is in medical technology. I'm all about bringing technological innovation into hospitals, private medical centers, things like AI, all these new electronics, things like that. I'm really all about bringing that into the workforce. And that's why I chose the degrees I'm doing. And I think Python is a great way to implement that. So I've been having a lot of fun programming inside of uni, outside of uni, at work. So keen to share about some of the stuff I've been doing.
That's super cool. It kills me sometimes on the technology that people in university and high school have access to now. God, I would have loved to have that back when I was your age, just a young whippersnapper. It would have been cool. So it's so cool that you can tie your, curiosity for the world that we live in, your scientific mind and all that stuff, and you can tie it together with the technology that you have at your fingertips. It's just like the perfect time for someone like you who's so switched on and just is eager to build change and explore and discover, and you have those tools on your laptop in your own house. It's super cool. So all right, so let's dive into this. Now let's start with the university piece, right? You've built some incredible stuff through university. Now everyone, this is going to be pretty technical, so pay attention while you're driving your cars and sitting there and, focus, all right? Because I'm learning along with you. I read through some notes Victoria sent me before, and it went straight over my head. So why don't we start with the first project? It was the blood oximeter, right?
Yes, yeah, pulse oximeter to measure.
Pulse oximeter. See, I even got the name wrong.
Close enough. It works with the blood. Key component with that.
That's all right. So it's right there. So you go for it. What's it about?
Yeah, so you'll see these little devices a lot in hospitals. So they're the things that will, you kind of clip them onto your finger or sometimes your toe. But basically, they're just measuring your heart rate, your blood oxygen levels, measurements like that. Those are the kind of two main ones. And so I'm in my fourth year now. So 2 years ago, we had to build one as a university project with a few others in a team. And yeah, so we had to build both the hardware and software for this device. We had to kind of start from scratch. So, we got the microcontrollers out. I believe we used an ESP32 for those who are,
Cool.
Big hardware, firmware lovers. ESP32 is really good. And so, yeah, we coded up the hardware and we had to do a bunch of signal processing with the data we were collecting from our sensor. We did all that signal processing in Python, and we got to make a really pretty GUI with a cool Python package, cool Python API. I forget the name. I think it's like PyGUI or something like that.
Okay.
But it was really cool. And yeah, that was basically the project. We were putting together sensors, hardware, communicating with it in Python over Bluetooth serial. And yeah, in the end, like we got a good mark for it. I will say though, like funny story, we stayed up till like 3 a.m. the night before of the demo at uni. So the demo was at 9 a.m. I was in the lab at like 3 a.m. the night before, making sure everything worked. But it paid off.
Wow.
Yeah.
That's super cool. So just for my information with this project, what made you choose this specific device to create?
Yeah. So, well, we all had to make the same device. So for that subject, yeah, our teachers were like, oh, we want you to all make a pulse oximeter, but the way at which we approached it, technically, and like what signal processing techniques we'd pick, etc., that was all up to us. So there was little room for creativity.
So that's really cool. Coming into this, and this is where I find this really interesting. So this was part of which degree?
My biomedical engineering degree.
Okay, this is the biomedical one. Now, coming into this, did you have experience with technology to that level? Like you're talking about microcontrollers here, Python, Bluetooth modules. You would have to write your own functions there to some extent. There's a lot of stuff to learn here, let alone managing the actual medical side of it. You're talking building something from scratch, coding it, making sense of the data that the sensors are bringing in. It's almost like a full stack app, right, of stuff that you had to figure out. So what was your experience before you jumped into this? Did you have any experience with this stuff, or was this learning it all from scratch?
Yeah, so I was in my second year at the time. Before that subject, I had never worked with software and hardware together, if that made sense. So I had So in my first year, I did a introduction to Python course. That's what I had up my sleeve at that point, and I knew a little bit of C from first year as well, but they were very separate concepts at the start, right? Like the whole subject with the pulse oximeter was about bringing things together, watching like separate parts become like a full stack, like in my opinions, which was really cool. But yeah, at that point, all I had was the Python knowledge, and I knew some object-oriented programming from my computer science degree.
Yeah.
And so I guess, so when I was building my GUI and all the signal processing stuff, I actually did it in an object-oriented framework. So I had all these, but that was all from my comp sci degree. A lot of the people I was studying with weren't doing computer science, and I was thinking about it. The level of, I guess, knowledge of that programming, especially in the C part, was quite different. Like I felt that there was a bit of a gap, and I kind of felt bad for those who hadn't been experienced to computer science. I was lucky enough that I was, but some of them didn't know what classes and functions fully were or how to implement them for this project. So I'm lucky in the fact that I had that experience.
Okay, so that's the catch, right? I mean, there's a huge learning curve here, and you're I'll say fortunate, but I also think you're slightly crazy for doing both biomedical and comp sci at the same time.
Yeah, I mean, I tortured myself a little with that one.
Okay, so you had that experience, but you still, like, there was still a lot of learning involved here, right? Bringing that stuff over, integrating it all together. was there a process that you went through to figure things out? So I guess, and I think thinking about our audience, the people watching and listening to this, right? A lot of people are interested in building stuff, and let's just very generically say that this is kind of like an IoT project, right?
Yeah.
It's not connected to the network and whatever, but still you're working with a little device, you're building something out of little microcontrollers and coding it yourself, maybe using whatever version of Python, MicroPython, whatever it might be, right? But you're putting something together to make a little device that performs a task, right? So what did you do? What process did you go to learn that? And I'm phrasing this question in such a way that I want to inspire people who want to do these kinds of things, maybe just in their own house with a Raspberry Pi, or pick up Arduino or whatever it is, right? So what did you do to kind of learn what you had to get this over the line?
Yeah, that's a good question. I think so our teachers were really helpful in the fact that they encouraged us to build system diagrams, just like to visually see first, where's the information flow going to go from? So from one point in your code to another, like just visually map out where are things going? Because, there's so many connections and flows of information. And like I think I sent it in the paper to you. We had a system diagram, all these different boxes and, like separating the hardware, software, this part of the hardware is going to go to this part of your code. Mapping all that out was really helpful for me.
Yep.
So yeah, system block diagrams. Whenever I build a big system now for a project, I always draw one up and I refine it as I'm building, because sometimes, things change, the way you implement things.
Well, as you're learning and things break and you're like, oh, actually, I need to implement something else in between. I've got to redo this diagram, right? It's actually really cool that you mentioned that. I didn't know you were going to say that. So, by the way, this is completely ad hoc, this interview. We haven't discussed anything in advance. Yeah. With our coaching program, the very first thing we do is we get people to essentially mind map their entire project so we can visualize the data flow. And it ends up being a system diagram in a way, which is pretty cool. So that's awesome. And so when it comes to the Python side of it, and I hate to push on the Python, but this is a Python podcast.
Of course, why not?
So what was some of the highlights with Python in this project? You said you used Python to create the GUI, the GUI, but you also had to interact with a Bluetooth module, right?
Yeah.
So was all this written in Python, everything?
Yeah, so everything that was not on the hardware was written in Python. So as I mentioned, all my Python code was written in an object-oriented type of framework. And for me, I did that because at that point in time, I had been doing it a lot at uni and I found it to be quite efficient. So I had like a Bluetooth module, which would connect over serial to the microcontroller. That class would interact with my GUI module, and all those GUI modules had those functions to like plot the graphs in real time. Yeah, so in that way, Python was really good because everything was really encapsulated well. And plotting and signal processing in Python, there's a lot of good packages. For example, if you want to do an FFT in Python, a lot of good packages to do that. So it was really helpful.
That's cool.
Yeah.
Nice. So with the overall project, now I want to move on to the next project, but with this one, what was, if you can share it, I don't know if you're allowed to talk about this stuff, what was the end result? I mean, you obviously got a grade for it, but does this get used somewhere, or is it just purely for the sake of this project and now it's done?
Yeah, so our team and I, we got a high distinction for the project, which was
nice.
Which was really, really, really good to see, like all the hard work paid off. It hasn't been used for anything else because it was just a group project. Okay. And it kind of gets done every year. So I don't think we were technically allowed to remove it out of our year. So I could maybe publish the results online or something. I don't know. Pay people to.
No, fair enough. That's fair.
Yeah.
Well, what I like is these projects that you've built and the things that you're working on are getting progressively way more advanced. So that was the I want to say the simplest out of the three things that you've shown me that we'll dive into. So the second one, Oh, yeah. I don't even know how to pronounce it probably, but anyway, it's for sleep apnea, right? So what
Yeah.
was tell us about this second project that you built?
Yeah. So this one was much more recent. This was another sensor that I built with a larger team at uni. So six others last
Ooh.
year in about October. And so that medical sensor, it's a thoracic pressure sensor. So for context, your thorax is it's kind of a region in your body around your chest area, including your lungs, your heart. I don't know if you can really see here, but it's kind of like this area here.
Okay.
And
Yeah.
so that's your thoracic cavity. And so a bit of medical knowledge because I'm an enthusiast and I will sprinkle it here and there. But your thoracic cavity, as you're breathing in and out, is going to have a bunch of pressure changes inside, like air pressure naturally as you inhale and exhale. Um, but with people with sleep apnea, those pressure changes are much more drastic, right? Because if you're sleeping at night and all of a sudden your airway is cut off temporarily, you're going to have this big surge of air pressure in and out when it comes back.
Hmm.
And that's actually really not good for the heart. So for this project, we actually collaborated with a clinical school at UCID, so someone that was separate to like this academic learning. And they said that there is actually no like mainstream way to detect these pressure swings in the thoracic cavity non-invasively. So this sensor was something that we designed to just put on the skin, not invasively. The most common way is to like stick a tube down the throat. That's a bit
Ooh.
too uncomfortable, and like no one wants to go through that overnight for a sleep study.
Oh my gosh. Yeah, that sounds
So
terrible.
yeah, it's pretty invasive. Like we were looking at the pictures of what we were working with initially, and yeah, they put like a whole balloon down there into your diaphragm, and that's how they measure the pressure. Um,
Wow.
yeah,
Okay.
you guys can search that up if you'd like. But
Mm.
uh, that was the motivation to build a sensor that was able to record these pressure swings non-invasively, just on the skin. And yeah, we wanted to measure them because they actually have a big effect on the heart. So if you have really drastic, we call them swings, like very big jumps, that's often a sign of early onset like cardiovascular disease, because
Mhm.
there's a lot of strain on the heart during those episodes. So we built the sense of 3 months. We started from scratch, um, and my role was I did a lot of the electrical stuff this time. So
Cool.
yeah, so we built a PCB actually for the sensor. I did help design the circuitry. Again, working with some microcontrollers as well. But how our device worked was we were measuring the impedance. What we did was we actually put electrodes on the body. So kind of like around
Yep.
here,
Yep.
we built a circuit. It would actually sit on a watch on your wrist,
Yep.
and we'd have cords from the watch going up your arm to these electrodes. So
Okay. So
we'd shoot in,
for the audio listeners that you're talking about your chest, you'd put electrodes on your chest.
yeah,
Okay.
on our chest.
Okay. Yep.
And we'd shoot in roughly around 10 microamps of current into your
Ooh.
body. So that's a very small amount, like
Yeah.
given what is like currently out there. And what
Yeah.
your body does is it actually brings back out a signal. And that
Yep.
signal will go back down the cords into our watch, into our circuitry. And from there, we can actually measure the impedance of your thoracic cavity. So for those who don't know, impedance is like electrical resistance inside your cavity. And that
Mhm.
actually correlates well with thoracic pressure. So that's the research that we did. And so this is where the Python came in. Like,
Yep.
also let me know if I should explain things a bit
No, that's
more. And
okay.
it's yeah.
Believe me, I will cut you up. No, I'm kidding. I'll remind you if there's something that you need to explain. But no, please keep going. This is awesome.
Yeah. So where the Python came in was, so we had the hardware that was setting in a signal, setting in like, yeah, electricity. You had a electrical signal coming back out of these electrodes, going back into our circuitry. What we did was the Python would take that signal, it would signal process it. So when I say signal process, we'd apply some sort of filter,
Mhm.
usually, and then maybe some thresholding to extract respiratory pressure information from this signal. And so from there, we were able to track what the pressure is looking like inside the thoracic cavity. So
That's
we were
cool.
able to, we'd have the original impedance signal, so the one that came raw out from the chest, and then we'd have the filtered signal. And then you can see where like a swing episode happened. And it was really cool to see. We used patient data from online first. We wanted to test it not on a person first, just in case there was, we designed it so that there would not be any electrocution possible, but just in case, obviously, we don't want the uni to be mad at us. So
yeah, fair enough.
but it worked, and we were able to capture these swings, and yeah, it was really fun to build.
That's really cool.
Yeah.
So what a cool project, first of all, and it's solving a real need. That's what I love about it. You're solving a real world problem, right? It's the first project that we talked about first is cool, but that stuff exists. This doesn't exist. Yeah. So you could make some real impact and really help people who just can't go through the tube experience and try and sleep an entire night with that balloon in there and stuff. So that is very impressive. And so the question is, from me then, as a follow-up to that, is where did Python come into? I know you've already mentioned a little bit, but are you able to go into the depth a little bit more about the Python usage in there, just for the people who criticize me for not talking Python on my own podcast? You go. What do you have?
Yeah, so Python played a big role in this as well. So again, so the signal processing, sorry, the detection and the signal processing of that original signal we get from the body, that was all done in Python. And the actual, again, kind of like the last project, the Bluetooth module that was connecting, for example, our Python code to the microcontrollers that were in our circuit, that was all written in Python as well. So we used a Bluetooth API to connect to our microcontroller, and that was a Python-based one. So yeah, again, all the statistical algorithms, any data analysis we did as well, we did in Python of our results. And we built another GUI pretty similar to last time, and it had like a data log where you could record events like overnight, because the idea was it was used for an overnight sleep study. And so that whole user interface was done in Python as well.
That's cool.
Yeah.
So look, so here's the thing, and I really appreciate that you're simplifying a lot of this for me mostly, but also for the audience.
Yeah.
It's one thing to say something like, we created a GUI, we interacted with the Bluetooth module, we used data visualization to visualize some of these signals and these reports, right? That to me is, and I appreciate this, it's a high level, almost like pseudocode way of saying it. Yeah, we'll visualize the data when it comes out. But the actual implementation of doing that, you have to learn all sorts of different libraries. You have to import whatever the Bluetooth module is of a library of a PyPI and figure it out. I mean, you've got to read the docs, you've got to do that. So there are a lot of different libraries there that you probably had to interact with for the very first time, maybe pulling on some knowledge from the first project, but let's just say you were doing it for the first time, right? How did you learn those? Like you go, okay, you have to Google, what library do I use to solve this problem? And then you go from there. What's your process?
Yeah, good question. So yeah, I definitely worked with a lot of libraries I hadn't heard of before. Sorry. And that was especially for things like actually the filtering of the data. So when I mean like filtering of data, often we apply like mathematical kind of filters and things like mathematical equations and translations to a signal. So that those are actually there are Python APIs that do that. And I didn't realize this because I used to do it manually in Python, write out the equations myself, and it would take a while. No, like when I found out these APIs existed, I was like, wow. And cut down my work from like 4 days to or maybe like 3 days to like an hour, which is really a big difference. So what I did was I would actually just look up on Google Python API to implement a Butterworth filter, for example. So they actually have like an API called Butterfilter Python or something, and you just run the API on your signal, and then bam, you get a result.
That's
So
cool.
Google is a big help. Documentation. Yeah, like I read a lot of Python API documentation, and I didn't use all of it. So sometimes you have to experiment. I downloaded a package if it just wasn't working or if it was just outdated. And sometimes, yeah, I got a hold of really outdated packages. You just move on. It takes a lot of work to, I guess, research and see what works best for you. But,
Mm,
you do it once, and then for the next project that you do, you kind of have that stored.
yep.
So, so now for the next project I'll do, I have those tools now. So in my opinion, it's worth putting in the research and a bit of that extra work at the start so that, pays off dividends in the future. Yeah.
Nice. I love hearing that because, it's so easy to get stuck into just, we say this all the time, and some of our listeners are probably groaning right now. Oh, here we go, Julian. It's so easy to get stuck into just watching videos and reading books, and the real work and success and progress comes in when you actually implement, right? So I love that you were just experimenting. Let me try this. Let me try this. Let me try this library. Let me try that one. See what works. See what's and that's another big problem as well, which we won't get into now. But you can find a lot of stuff that's out of date that the maintainers
Yeah.
have moved on from that package and gone, yeah, no, I don't get paid to do this, so I got no time. But yeah, that's one of the real challenges I think of people get stuck in when they try to build stuff like what you're doing. Maybe not at that scale, but still when they're building, they get stuck in the consumption of videos on how to, and here's a tutorial and here's that, instead of just trying it out and experimenting and seeing what works. So, so this is really cool. And I love this idea. And so the question for me is, what's the end result of all of this? So it worked. What happened after that?
Yeah. So again, so for the university subject aspect of it, so I received a 90%, which was really great. Um,
Wow.
yeah, no, I'm really glad that, yeah, thank you. A lot of the hard work, these projects, they do take a good few months. So all the hard work paid off. Um, and yeah, again, we were collaborating with this external clinical school, and they really liked the idea. And yeah, so we had some good interactions with them um, after the university side of it was done in terms of how we could implement this into a sleep study,
Mm,
which is really good. But yeah, things are
okay.
still ongoing and in process. So
That's right.
yeah,
I want to be able to say, oh yeah, this thing's now used across all of the hospitals in Sydney or whatever, right? That would be
oh,
super cool.
oh yeah, that takes a long time to implement though. Like half of what we learn in our degree is like how hard it is to actually just take a prototype that you build and then actually scaling it to just, nationwide use and all the regulation and oh
Yeah.
yeah, it's a whole different ball game. Yeah.
Yeah. The medical side of it, no, keep me out of it. I don't want to deal with that.
Yeah.
No, but that's super cool. I mean, this is the kind of stuff that gets me excited about technology and Python in general. You can, you know, with an idea, you can really just put stuff together in your own living room, essentially. I mean, yeah, okay, you created a PCB that's now we're getting up there. You need a workshop or you need all that
Yeah.
material. But now you can even get PCBs made up at different companies that'll print on demand, right? It's just
Yeah.
mind blowing what you can get done. But it's super cool that you're able to just do this in a couple of months through university. That's amazing. You should be really proud. I love it.
Thank you.
All right. Now, we're
All
going to move
right.
to the last one. Now, this one I couldn't make heads or tails of because we're getting into quantum something
Yeah.
stuff.
Quantum. Yeah.
So,
Quantum
so
physics.
quantum physics.
Yeah.
Okay. I was
Yeah.
going to say quantum mechanics. I don't know if that's the same thing, but
Yeah.
look, thank you for humoring me.
Yeah.
I appreciate it. You made this old man feel intelligent. So this is the stuff I love, but have no idea about. And to sit there and study it, I can't dedicate the time. So this to me is very exciting and interesting, but I don't understand the why. So let's start with the what. What is it that you were doing in this space, and then we'll go into the why.
Yeah. So this time last year, I was working as a data and machine learning engineering intern. So at a quantum-based lab. So they were all about performing quantum experiments. For those who I'm not fully sure, it was kind of based around quantum computing and looking at how we can use different small, I'm going to call them microparticles, but they're much smaller in terms of they're very small. Basically how we can turn those into something called qubits. So I can go on a long, have you heard of qubits before? Yeah.
I have heard the term. Yeah.
Yes. So if we think about a classical computer, this is kind of like the way I like to introduce the whole idea of quantum computing, because I feel like it's a big hot topic.
Yeah, please.
Yeah. So a regular computer that we use, you've got bits. So bits hold information. And these classical bits, which kind of make up the information process of a computer, they kind of have, they're binary, right? They've got two states. You've got a 1 or a 0, and you put all those together, and the different, I guess, combinations and stuff, that's what makes up information inside of a computer. And the way at which information is like transmitted is based on these bits. In a quantum computer, what makes, I guess, people know that quantum computers are much more faster. Like their computations that they do are significantly faster than a classical computer. So that's because instead of classical bits, we're using qubits. Qubits are really small particles that, the best way I can explain it is, instead of having finite states of like 1 and 0, there's kind of like an infinite amount of states between 1 and 0 that information can be stored in. So you've got kind of like, it's through a process called superposition, but basically information can be stored at kind of levels in between 1 and 0. So the transmission of information is significantly times faster. Superposition is essentially the transfer of information between these qubits or these particles kind of instantly. So everything is working really fast. But there's many different ways to make qubits. So what my lab was doing is using ions. So there are a bunch of different ways. You've got, there's superconducting qubits, there's photon qubits, all these different ways to make them. But so in my lab, we were using ytterbium ions. Ytterbium's, it's an element, you can see it on the periodic table.
Okay. Yep.
Some fun fact. These ytterbium ions, so the best way to explain this is, imagine a Newton's cradle.
In Newton's cradle. Okay,
Newton's cradle. Like,
yep.
I actually, do you want me to bring it down? Like, I have it right here on my shelf, or do you want to?
Go for it.
Can I do it? Let me be 1 second, because it's a great way to visualize what's happening. Hold on. Okay. So what we did at this lab was, you put the ions in a chain like this, and this chain's we're in a vacuum chamber at the moment. And if you shoot a laser at this chain, so if I start if I move this, you'll see that they're kind of like oscillating.
Yeah.
Like this. But they'll individually oscillate like that, but the whole chain's actually moving as well. So if you move the whole chain, you kind of got all these interactions.
Yep.
And you'll see that over time, they kind of slow down. So that's what my work was. It was characterizing how these ions kind of change frequency in this chain.
Okay.
Because you've got like this communal chain, but then individual movements, and just tracking that frequency change. Yeah.
So what are you aiming to understand by tracking that change?
Yeah. So when these ions are, we call it drifting, their frequency is drifting off. That's not a good thing. So ideally in a quantum computer, you'd have qubits where their frequencies and oscillations are very controlled. And that's how the transfer of information and such is in a very controlled environment. The aim is for our oscillations and everything to be controlled, we're trying to understand why this drift is occurring, like what the cause of it is. So what my project was to create a model that was able to predict and estimate, firstly, what the drift is, and then seeing, is there something causing that? Like, is there a machine in the lab that's causing it? Like if it's drifting at a certain pattern or frequency, is there a cause for that?
Okay.
Yeah, if that makes sense. So
yeah, that does. That's super cool. Thank you for breaking down quantum computing for me. I was not expecting that. That's super
it was a
cool.
it was a very high. That's a very high level approach.
Yeah.
And like even myself, there's so much there's so much that I don't know, and that there's so much to talk about with quantum computing. It's very complicated, but it's fun.
I can't even imagine. But thank you for trying and for giving us that very simplistic overview. For anyone who's listening and watching who does understand this intrinsically, don't judge us for breaking it down to the simple level for my brain, okay? But no, so that's really cool. And so where did Python, and I'm always going to come back to the Python here. So where did Python come into this measurement and tracking?
Yeah. So basically it was a bunch of data analysis and the building of a Kalman filter. That was all done in Python. So
okay, what is the Kalman filter, if you can define that?
Yeah. So basically it's a mathematical estimation model. It's done a lot in engineering to estimate a signal or a quantity over time, because we know that in real life, whenever we have a series of data, sometimes, there's a little bit of error in if you have like a series of data points. What the Kalman filter does is you feed it your data and it will kind of apply like a corrective estimate of what's meant to happen.
Okay.
And it's a filter, so it kind of cleans your data a little bit and kind of tries to filter out that error that we're seeing in real life.
Cool. Okay. All right. So back to the Python and the Kalman filter. Where does this all work together?
Yeah. So I coded the Kalman filter in Python and then visualized what the I guess the frequency drift data would look like if it was cleaned up, if that makes sense. So what the cleaned behavior of these qubits were doing.
Yep.
And for those who've seen the Kalman filter before, there's a lot of mathematics behind it. There's a lot of matrix multiplication and transposition and everything like that. And you have to multiply all these matrices together to get an end result. And that's like your predicted data point versus your actual data point that you give the filter. And so all that mathematics, I basically coded in Python and all the algorithms, and then you put it all together and you get a new series of data points and you plot it and you see, I guess, what the cleaned version is. Yeah. That's
cool. Well, what kind of what Python libraries and modules did you use for this?
Yeah. So I use NumPy, of course. So for all the matrices applications, always need NumPy. Nothing else really, because I built the filter from scratch, but there are, I think, one or two APIs in Python. It's like a common filter one, which is cool. Yeah.
Wow. This is cool. So first of all, this is so impressive. I almost lost for words at how, and everyone knows I don't stop talking. So I'm incredibly lost for words at just at your age, not to put age on anything, but just how incredible this stuff is, right? I'm
thank you.
Calling it stuff is an understatement, right? And doing it a disservice. But the thing that gets to me about all this is that it doesn't matter how advanced and technical and almost out of this world the stuff you're working on is, the fundamentals are the same. They're still there. You're still using NumPy, which is a library that people use to do all sorts of number crunching, financial data, whatever it is. And people use that at home. So it's when you hear that same library that I might use on my computer at home to do a bit of some calculations, different things like that, data gathering, manipulation, whatever, that is also being used at your level of, I don't even know how to describe how you're using it, but in quantum physics, it shows that I hope people can be inspired as they hear this and go, understanding the fundamentals can get me anywhere. And investing time and learning and building and experimenting and just playing with the stuff and having more than anything the drive to get up and do it is what's going to get you there, right? You're using the same building blocks, the same pieces, the same Python concepts of, you mentioned OOP, object-oriented programming. You mentioned, you're dividing stuff into functions and classes, and, you'll learn some best practices, one function, one use, these kinds of, laws and rules of Python. They still apply to things of this scale and this intensity. So I guess to wrap this up, because by the way, this is incredible. Actually, no, before I wrap it up, I just want to ask you, how long were you working at this quantum lab that you were doing this work at?
So I was working there for 7 or 8 months. Yeah.
Okay.
So
but
it took
you were originally there
while.
for a short amount, right?
Yeah. So it started off as an internship for 6 weeks over the summer, and they really liked the direction of the work, and so we kept working on this model for 6-7 months, which was crazy. Yeah.
So cool.
Such a good experience.
I love it. They appreciated the work you were doing after just 6 weeks. They said, stay for almost a year.
Yeah. It was crazy.
Cool.
I learned a lot from them. So.
And is there any, now this was outside of university, right?
Yeah.
So what's the outcome of the work? Does this get taken anywhere? Are they going to continue the work now that you're not there anymore? Or what's the go?
Yeah. So I believe they're either still continuing the work, or there may be talks to eventually using this as part of a publishing, like a published paper. I'm not sure. That was mentioned before I left.
Okay. It would be
but
cool.
I think they're still working on it. It would be very cool if it was part of a paper, but we'll let you know if anything happens. Yeah.
We'll get a petition out there. We'll go knock on their door and, oi, put this in a... No, I'm just kidding.
Yeah, we can make it happen.
We'll make it happen. Send them this podcast episode.
They'll have a nice little shout out. Yeah.
Yeah. Nice. No, that's really cool. So what inspires me beyond the technical, and I hope I haven't done your technical background here any disservice, right? Because you've worked your butt off for this stuff, as I know personally over the years, right? So you've worked so incredibly hard to get to this point of understanding, of knowledge, of capability, and that said, there are some key traits that you would be deploying, or you'd be utilizing, or you'd be working on no matter what you tackle, right? Such as just getting in there and doing the work, just making the choice to have your morning coffee and get to work, right? So what advice would you give to someone else who is interested in this stuff and wants to get into the building, wants to get into exploring these kinds of interests of theirs and getting into all this? How do you push through and just do this stuff? It's not easy.
Yeah, no, it's not. And I think, I don't know if what I'm going to say is going to sound cheesy to people, but I think what got me through is that nothing is impossible. Just saying that to myself, because really, you can do anything as long as you put the work and the effort into it. I don't believe that, there's something that, if everyone says, oh, that can't be done, don't let that be the thing that stops you. For example, again, with the Kalman filter that I built, I had people say to me, other students, other friends of mine who had been doing it in class, oh, it took me a month to build that. It's really hard. You're not going to get it first try or second try. And you'll come across people like that. And sometimes that person is yourself, but you can't let that demotivate you from trying. That would be my biggest form of advice. And I think as well, I feel like imposter syndrome is something that's quite big in the programming community. I know I felt it. I've felt it at work whenever I work with a bunch of engineers or something. Don't let imposter syndrome as well be the thing that holds you back.
That's cool.
Yeah,
That's cool. I'm so glad you said that. We that's one of our big four things that we always have to tell people, drop the imposter syndrome and just do it, So out of curiosity, how long did it take you to make the Kalman filter?
Yeah, so my original Kalman filter took me 2 days to build, which isn't like, because when you're writing out the math and stuff, it doesn't actually take that long to build. What took me long, what took me to be fair, it took 7 months because I wasn't working full time. I was working very limited hours a week, but the mathematical model and all the research I did, which was very much off script in the fact that a lot of the maths, the models I made up on my own to pair with this filter, that's what took the time. And even with that, that's something I had never done before, but just because I hadn't done it before, and I didn't let that stop me from doing it. I'm all about giving things a go. Even if you don't get it first try, don't let that demotivate you. Yeah.
Yeah, that's cool. No, I love it. Yeah. I love hearing this motivation thing, because that's ultimately what it comes down to, right? You can learn the tech, you can be as technical as you can, but if you don't have the motivation or the confidence in yourself and just the willpower to get up and start coding, you're going to struggle. So last question from me before because I know this is a long episode for you and you're probably like, oh my God, just let me go, Julia.
I've been having fun. Yeah.
Oh, good. Excellent.
Yeah.
My brain's melted by the end of this, but no. So the question I have for you then is, and this is more of a modern day problem, but there are so many distractions around us right now with, your mobile phone, with social media, with TV, with, and I won't say friends are a distraction, but when you're pushing hard on building something, sometimes too much socializing can actually slow you down. Like when we were building PyBytes starting from scratch, there was a good solid period of time where we were like, no, we have to sacrifice going out and doing things because we need to be here coding and building and creating. So how do you balance all of that? And have you found that to be a challenge at all?
Yeah, I think it's been a challenge at the start to balance, uni with work and then socializing and then sports. I think I work well with timetables, as in I will kind of timetable my time to which is, it's quite, I don't know, I guess, I don't know if you call it robotic in a way, but sometimes I just block out a day to work on this problem or this task. And I feel like it's kind of a habit for me now to just kind of stick to it. That it helps me a lot because I get distracted really easily. I go on my phone so often. Honestly, I turn off my phone and kind of just put it out of arm's reach whenever I'm coding really hard on a problem.
Cool.
Or I just have to really lock in with the maths or something.
Mm-hmm.
But I think, I take breaks as well. Breaks, especially when there's been times where I'm debugging a problem for over 12 hours or debugging a piece of code. Oof. Debugging is, it can be a good thing, but sometimes it really just drains you. So taking good breaks when you're not getting anywhere is sometimes the best thing.
Yeah, walking away from the problem. Yeah. It's cool. We talk about these concepts and techniques a lot through the podcast, through our writing, our coaching, all that stuff. And it's really interesting to me to hear this from you, someone that I've watched grown up and who is now doing incredible things, but you still use the same techniques that we use for other things, right? And so, so what you're talking about with having a timetable, we call that time blocking, right? So we get our calendar and we block out times for specific things. I did this in the corporate world. I do it now between, 11 a.m. and midday every day. That's my workout time. And you're encroaching in my workout time because it's 11 o'clock. No, I'm kidding. But then there's also, 9 to 10 a.m. is deep work and the phone goes away.
Yeah.
My computer's set to go on do not disturb. And just like you turning off the phone, putting it on the side, it's something we constantly tell people, turn off your notifications, put your phone away, put on do not disturb. So this is really cool. I love hearing that. And that using and walking away, right? We promote walking away because your mind gets into diffuse mode when you go for a walk down the street, you go for a shower, you go do the dishes, whatever it might be that we do in our day to day. That's when the things connect in your head, the ideas, your memories, the stuff, sleep on it. So I love that.
Yeah.
That is so cool. And you didn't even do any of my coaching, and you've learned all that stuff. That's incredible.
Oh, don't say that. Don't say that to your viewers.
That's right. That's right. We're open. We talk about this stuff all the time. So Victoria, that is so inspiring, the stuff that you're doing, and I can't wait till you're walking on the moon or Mars or wherever. Right?
Yeah.
Stuff is crazy. So you're going to change the world. I know it.
Thanks, Kaz. That's means a lot.
No, that's all right. So look, you read. We always ask a question as we end the podcast. What are you reading? So talk to me.
Yeah. So I do reading a lot of research papers, actually, just on like different medical topics. I read a lot about neuroscience, actually, like how, breakthrough developments in like mental health treatment, and how genes affect how your brain grows and what you're capable of when you're an adult, how genes at your birth are capable for that, like all that cool research stuff I love. So
that's awesome.
Yeah, we
should do a regular sync. I want to learn all this stuff from you. I love having these kinds of conversations. It's great.
Yeah, no, it's good. I'm all about just continuously learning. I never really want to stop learning, so always have a paper nearby. Yeah.
Let's get scientific papers.
I sound like a nerd, don't I?
I can just picture it now. I grab your morning coffee. We're all picking up novels and other technical books. I just grabbed this 5,000-page scientific paper on neuroscience. That's awesome. I love hearing it. That's very, very cool. Well, I'm reading, and I did show you this before the podcast recording. I've just picked up this book by Yuval Noah Harari, his new book from September last year called Nexus, A Brief History of Information Networks from the Stone Age to AI. So this is highly recommended by Bob and one of our community members, Craig. When I met with him the other night, he was like, "You got to read this, mate," in his strong UK British accent. So British, New Zealander, Kiwi hybrid.
British New Zealand. Interesting.
Yeah. He's special like that. It's cool. But no, I love you, Craig. So I'm reading that. I've got to open the first page because I only just bought it yesterday, but I'm very excited to dive into it because I loved his other books. So you're gonna have to read it too. And we can read it together.
After you finish reading it, I'll take it from you.
You borrow mine.
Sorry.
Get your own.
Okay, all right.
Oh, excellent. All right. Well, look, Victoria, you tried to take it. It was such a pleasure having you on here, and you're doing such cool stuff. And this is, you haven't even finished uni yet. I can't wait. You're going to do so many cool things. And is there anything else you want to add before we drop?
I just want to say thank you so much for having me. This is, first podcast. This has been a great experience.
Oh, that's cool.
Yeah, really, really appreciate it.
Oh, my pleasure. Happy to do it. Sorry we didn't do it sooner. We should have done this years ago. This is really cool. And when people want to follow you and say hello and whatever, where can they find you? I know you're on LinkedIn. Is that it, or anywhere else you want to?
Yeah, I got Instagram, Facebook. I can happy to put the handles up somewhere in the editing feed.
Maybe not the personal ones.
Oh, okay. Then just LinkedIn. Just LinkedIn. True. I forgot.
Keep it to the professional stuff.
Yeah. Just my LinkedIn handle is there.
Okay, perfect. I'll put that in there.
Keen to connect.
Everyone, yeah. Victoria's doing great stuff. Please, follow her and give her some motivation and cheer her on as she goes through this stuff. This is great. So we're going to end it there. Victoria, thank you again. Pleasure having you on the podcast. Everyone, thank you for tuning in, for listening, for watching, and make sure you share this out with people because, again, very special episode for me personally, and I definitely want to get people inspired and show them the cool stuff that Victoria is doing, that anything's possible. And yeah, we'll see you next week. Thanks for everyone for joining. Catch you later.
Thanks, guys. See ya.
Hey everyone, thanks for tuning into the PyBites podcast. I really hope you enjoyed it. A quick message from me and Bob before you go. To get the most out of your experience with PyBites, including learning more Python, engaging with other developers, learning about our guests, discussing these podcast episodes, and much, much more, please join our community at pybites.circle.so. The link is on the screen if you're watching this on YouTube, and it's in the show notes for everyone else. When you join, make sure you introduce yourself, engage with myself and Bob, and the many other developers in the community. It's one of the greatest things you can do to expand your knowledge and reach and network as a Python developer. We'll see you in the next episode, and we will see you in the community.